Friends, we are going to discuss the chemical properties of haloalkanes. Students, haloalkanes is very important as it is used for the synthesis of the different organic compounds. It is treated to be a synthetic tool in the hand of the chemist. So the chemical properties which are shown by the haloalkane is mainly because of its polar bond, that is C-X bond. So here students, the chemical properties which are shown by the haloalkanes, these are mainly four types. First one is the nucleophilic substitution reaction. Second one is the elimination reaction. Third one is the reaction with metals. And fourth one, student, is the reduction. So at first, we are going to discuss the nucleophilic substitution reaction. Nucleophilic substitution reaction. So first of all, that the haloalkane, student, it undergoes a nucleophilic substitution reaction. So what are the nucleophilic substitution reactions? So these are the reactions in which stronger nucleophile replaces the weaker nucleophile. And you must be knowing that what are the nucleophiles. So nucleophile, student, is the reagent which are electron rich, species. Hence, they are going to be nucleus loving. Nucleus loving means, student, that it is having the affinity for the positively charged center. Electron-rich species, student, can be of two types. One is the negatively charged species, which are like OH negative, right? It can be NH2 negative, right? Or it can be O negative R, right? Or RO negative, right? These are the negatively charged species. And the second type, student, is the species which have lone pair. Species having lone pair, like water. Water has got two lone pair on oxygen atom. Likewise, ammonia, which has got a one lone pair on the nitrogen atom. So in the nucleophilic substitution reaction, students, the nucleophile which will be more stronger, right, is going to replace the weaker nucleophile from the reaction. Now, let's take here the example. Let it be, we have this bond, right here. It is denoting the haloalkane. So here you know that we have the polar bond C-X is the partial positive charge and this is partial negative charge. So when a nucleophile, we are going to denote the nucleophile in this way, right? This is Nu negative. Negative sign is showing that it is a negatively charged species. So when it will be appearing, right, since it is stronger than this halide ion, right, it is going to just attack on the positively charged, or we can say the positive center, and the replacement will take place in this way, and the negatively charged halide ion, right, will be replaced. right? So here student, the nucleophile is just getting the halide ion replaced. So student, here there is a nucleophilic substitution reaction. If the nucleophile student is negatively charged, that time you can see here that the species which has been formed, right, this one, this is the neutral molecule. It is a neutral molecule. But if it is a species which has got a lone pair, right? If it has got a lone pair, that thing, let us take it this way, that it is having the lone pair with it. That time student, same thing, this is partial negative here, this is partial positive. To get back here in this way. So here the nucleophile. Now here you can see that a salt will be the formation, or we can say that formation of salt will take place. Right? So here the nucleophilic substitution reaction is taking place. First, where the nucleophile is negatively charged, where a neutral molecule will be formed, and where there it is bearing a lone pair, right, that time we will get a salt formation. That means we will have a product which will be positively as well as a negative charge on it. Right? Now we are going to see few examples of the nucleophilic substitution reaction. So here let us take few examples of nucleophilic substitution reaction. So the first one is the reaction with aqueous KOH. This will lead to the formation of alcohol. Right? So whenever we get haloalkane reacted with either KOH or moist silver oxide. So here I have taken this aqueous KOH which is being heated. We will get ROH and alcohol and KX will be formed. Similarly, we can have here silver hydroxide, though we are writing it in this way, but it is written as moist silver oxide. In this case also student, we will get ROH plus AgX, that is the silver halide. So in this reaction student, we are getting the alcohol formed. Next, we will discuss the second reaction, right? We have discussed just now the reaction of the haloalkane with the aqueous or moist silver oxide, which leads to the formation of alcohol. Next is the reaction with sodium alkoxide, which will lead to the formation of ether. Now here it is Rx plus RONA. This is sodium alkoxide. Right here, what will happen? This X will get react with this Na and it will form ROR. It is this different alkyl will form ROR dash plus NaX. So we will get a ether form. For example, if you take CH3, CH2Cl reaction with CH3ONA, that is sodium ethoxide, we will get here CH3CH2O CH3 plus NaCl. So here we are getting it the ether, that is methoxyethane. Next student, we can also prepare this reaction student, formation of ether from sodium alkoxide is known as Williamson synthesis. Now, student, the next reaction is with alcoholic KCl, and it is the formation of alkane nitride, which is also known as alkyl cyanide, right? So here, let us write down here first alkyl haloalkane, its reaction with KCl, alcoholic KCl. The product formed, student, is RCN plus KX. So here this is alkyl cyanide, or we can also write it as alkane nitride. Now this RCN is very important. Why? Because this RCN, this is alkyl cyanide, if its partial hydrolysis takes place, partial hydrolysis takes place in presence of concentrated HCl, right? That time we will get here form RCONH2. That is an acid amide is formed, and when the complete hydrolysis, complete hydrolysis will take place in presence of dilute HCl, right? So we have dilute HCl here. That time we will get carboxylic acid, right? So this is a carboxylic acid which will be formed, and when we get it reacted with sodium dissolved in ethanol, right? Or we can take, student, here the get the reaction done with the hydrogen in presence of the nickel or platinum. That time an amine is formed, that is RCH2NH2. So we will get here an amine formed, right? Generally, students, the amine which is formed here is primary nature, and this reaction, reduction reaction, is known as Mende's reaction, or it is known as Mende's reduction, right? So the alkyl cyanide which has been formed, which is being used to form large number of the different organic compounds, right? So the reduction can be carried either in presence of the sodium dissolved in ethanol, or it can be carried in presence of the hydrogen. It is a catalytic reduction can be carried out, and we get a amine, right? So we have discussed here few new examples of the nucleophilic substitution reaction. First was the formation of the alcohol, second was the formation of the ether, and third one is the formation of the alkane nitride, which is known as the alkyl cyanide also, and this alkyl cyanide is being used for the preparation of the different, we can say, different organic compounds like acid amides, carboxylic acids, and amine. Good morning, students. In our last class, we have discussed the chemical properties of haloalkanes. Few reactions we have discussed. Before I continue the topic ahead, this is a question. I will tell a reaction on the board, and you will try to solve it out. That haloalkane, what is going to be the product when it reacts with alcoholic KCN, potassium cyanide, and what will the product when it reacts with AgCl, right? So when the haloalkane reacts with KCN, the product form is RCN plus KX has been formed, whereas when haloalkane reacts with alcoholic silver cyanide, the product form is RNC plus KGX. Right? Can you just think that why we get the two different products is been formed. Here it is RCN, here it is RNC. So the student difference here lies that KCN and AGCN, the nucleophile is here cyanide CN. When the CN is an ambient nucleophile, it means that it has got two donor sites, right? And it is going to get bonded to the metal atom or through the group only one at a time, right? Cyanide. So if you see students go through its resonating structure, this is there. It is in resonance with the nitrogen. So here students we have got the two donor sites. One it is carbon, other it is nitrogen, right? This is the first thing. Now second thing is that KCN student, it is an ionic compound. Hence CN is a free ion, is a free ion in the medium. It can bond to alkyl group either through C by forming C-C bond or through N by forming NC bond, right? Now among these two bonds, that is CC and NC, C-C is stronger and hence group links through carbon and hence and therefore alkyl cyanide is formed. But AgCN student is covalent compound. So here we don't get CN as free ion. So we will not get the cyanide group, right, as a free ion here. Right? So here it's only through nitrogen atom cyanide group will bond to alkyl group. Hence, isocyanide, this is isocyanide is formed. Also, this thing is clear to you and the board is too visible.